All right, class. We are moving on to our another standard in Unit 1, and we're going to be looking at the quotient of fractions. So, quotient, we already know this from our vocabulary. It is the answer to a division problem. So, we're going to be dividing fractions. So, we're going to watch a video from Math Antics on that side of the screen while we take notes on this side of the screen. So, notice that this paper has already been posted to your class board for you to write down. And now we're going to do some examples. All right, let's go.
Hi, and welcome to Math Antics. This video is all about dividing fractions. But in order to understand how dividing fractions works, we first need to learn about something called reciprocals. A reciprocal is just a fancy math term for what you get when you switch the top and bottom numbers of a fraction. For example, if you have the fraction 1 over 2, and then switch the top and bottom numbers, you'll end up with 2 over 1. 2 over 1 is the reciprocal of 1 over 2. And 1 over 2 is the reciprocal of 2 over 1. And an interesting thing about reciprocals is multiplying a fraction by its own reciprocal will always give you 1. That's because you'll have the same multiplication problem on the top and bottom, so you'll end up with a whole fraction, which is always 1. Okay, that's nice. But what do reciprocals have to do with dividing fractions? Well, reciprocals let us do a really cool trick that makes dividing fractions easy. Whenever you have to divide something by a fraction, you can just multiply it by the reciprocal of that fraction instead, and you'll get the correct answer. And that's great news because multiplying fractions is so simple. This trick of multiplying by the reciprocal works because fractions are really just mini division problems. So when you multiply something by 1 over 2, it's the same as dividing by 2 since 2 is below the fraction's division line. And dividing by 2 is the same as dividing by 2 over 1 because you can turn any number into a fraction by just writing a 1 as the bottom number, right? But look, reciprocals. That's why multiplying by 1 over 2 is the same as dividing by 2 over 1. And it's true the other way around too. So really, it's kind of like you never have to divide fractions. You can just rewrite your division problems so that you're multiplying by the reciprocal instead. Then when you multiply, you'll get the answer for the original division problem. As always, let's see a couple examples of how this works so you'll really understand. Let's try this problem. 3 over 4 divided by 2 over 7. Okay, so the first thing we want to do is rewrite our problem. Instead of dividing by 2 over 7, we can multiply by the reciprocal instead. The reciprocal of 2 over 7 is 7 over 2. So our problem becomes 3 over 4 times 7 over 2. Oh, I should mention a mistake that a lot of students make when they first learn to divide fractions. Sometimes students take the reciprocal of the first fraction, the one that's being divided, or even the reciprocal of both fractions. But you only want to take the reciprocal of the second fraction, the one you're dividing by. Okay, now that our problem has been changed to multiplication, it's easy. Just multiply the tops, 3 times 7 equals 21, and multiply the bottoms, 4 times 2 equals 8. And we have the answer to our fraction division problem. So 3 over 4 divided by 2 over 7 is 21 over 8. So that's pretty easy, but let's try one more example. Let's try 15 over 16 divided by 9 over 22. Again, the first thing we want to do is rewrite our problem. We'll change the divided by 9 over 22 into times 22 over 9. Now all we have to do is multiply. But since these numbers are kind of big, I'm going to use my calculator to help. Let's see here. So we have, all right. On the top, we have 15 times 22 equals 330. And on the bottom, we have 16 times 9 equals 144. So the answer to our division problem is 330 over 144. Of course, that could be simplified for your final answer on a test, but we cover simplifying fractions in another video. All right, that's how you divide fractions. You just multiply by the reciprocal and you have your answer. But there's one more thing I want to show you. You already know that the line between the top and bottom number of a fraction is just another form of the division symbol. Well, that means you'll sometimes see fraction division problems written like this. This shows the top fraction, 2 over 3, being divided by the bottom fraction, 4 over 5. It's really just that we have a fraction made up from other fractions. The top number is a fraction, and the bottom number is a fraction. It just looks a little confusing because we have all these fraction lines here. But we can make it look a lot better. Let's rewrite this as a multiplication problem by taking the reciprocal of the bottom number, the fraction that we're dividing by, and multiplying it by the fraction on top. There, that looks easier to do, and it's really the same problem. We just need to multiply to get the answer. So 2 times 5 equals 10, and 3 times 4 equals 12. Okay, so there you have it. What sounded really hard turns out to be as easy as flipping fractions upside down. If you can multiply fractions, then you can divide fractions too. Don't forget to practice what you've learned by doing the exercises for this section. Thanks for watching, and I'll see you next time. Learn more at mathantics.com.
All right, so now let's just go over what we just learned to make sure that we know the steps when dividing fractions. So the video mentioned we will never have to divide fractions. Never divide fractions. Now, how can we say never divide fractions when we literally just did that? Well, we didn't actually use the operation division. We said we will not divide, but instead we would multiply by the reciprocal. Now, a way to remember reciprocal, we could say flip reciprocal. So we need to flip our fraction to get our reciprocal that we're multiplying by. Now remember, it is also always, we are always going to only flip the first or second. It would have to be flip the second fraction only. And this is all you need to know when dividing fractions. Multiply by the reciprocal and only flip the second fraction. So now, if you got this information and you're good, let's go back to the vocabulary. And if you already know about improper and mixed numbers, improper fractions and mixed numbers, you can go ahead and stop the video and go practice. But if you need some additional support or an explanation just to refresh your memory, finish the video and get the information on how to convert from an improper fraction to a mixed number. All right, I'm going to continue with that now. So an improper fraction is when the numerator, the number at the top, is bigger than the denominator, the number at the bottom. So we have 45 over 7. This is obviously bigger than the number at the bottom. So this is what we would call an improper fraction. And here are some more examples. Now, a mixed number is a whole number and a fraction combined into one. So here's some examples. 2 is a whole number, but it's attached to the fraction 1/3. So 2 and 1/3 would have to be a mixed number because we're putting together these two whole numbers and fractions together to make one number. And here are some more examples. So now the important part of knowing these two things is now how do we go from a mixed number into an improper fraction and back? How are we going to convert between these two? So I'm going to use this example, 2 and 1/3. So let's imagine we have our 2 and 1/3. Let me write this down. So here's our mixed number. And the first thing that we want to do, so step 1, would be to multiply the denominator times the whole number. So multiply 3 times 2, and we end up with 6. Then we're going to step 2, add 6. So add what we got when we multiplied 2 times 3. Add the numerator, so add 1. So we have 6 plus 1 gives us 7. So now we have our numbers that we need. Our numerator will now be 7. and our denominator will stay the same as 3. So now we just went from a mixed number to an improper fraction. Our denominator stayed the same as 3, and our numerator we got by multiplying 3 times 2, we got 6, and adding our numerator, and we got 7. So now, how do I get back from this number back to this number? Well, simply, I'm going to use long division. So 7 divided by 3. How many times can 3 go into 7? It would have to be 2 times. 2 times 3 is 6. I go ahead and subtract. 7 minus 6 is 1. So our remainder is 1. So now looking at this, we see that our whole number is 2. So 2 is our whole number. We're left with a remainder of 1 out of 3, our denominator. So 2 and 1/3 and 7 over 3 are equal, and this is the steps you would take to go from one to the other. All right, thank you.